Hi, I'm JJ, aka the Int Programmer. In my last video, I discussed how you can build a classifier to detect pictures of cats and dogs, using as few as 100 to 1,000 training images, and even lopsided sets of images like 100 cats and 1,000 dogs. That worked pretty well, but it only trained to recognize only pictures of cats and dogs. If we handed it some other picture, the classifier won't give any meaningful results. In this video, I'll demonstrate and benchmark using the Fast.ai library, how to build a classifier that identifies whether or not a picture is a cat, and another separate classifier that identifies whether or not a picture is a dog. Think of this like the Not Hot Dog program seen on the TV show Silicon Valley. Although identifying whether or not something is a cat, dog, or hot dog has limited practical value, this method can be used to build useful and automatic functionality in self-driving cars, mobile apps, and web scrapers, just to name a few possibilities. Now let's head over to the Jupyter Notebook. Okay, so here we're at the Jupyter Notebook. Now, if you've seen my previous videos, what I usually do is I'm just going to copy and paste the code that I've written in another notebook and talk about and demonstrate how it works. So here, let's start by importing our variables. And this may take a while, so I'm going to pause the video for it to catch up. Okay, the import's complete. Now, let's put the paths of our data sets. So the data directory should contain a dogs and cats directory that you've created in the last lesson. If not, go to my previous video or in the description below, and you can download that data set and put it in the directory labeled data and make this a relative path to that directory. The next one is a dataset called the Flickr 8K dataset, and I'll show you. You can download, you can Google it and find it, or you can just download it in the link below. So let's run that, and you can see here we have 1,000 images of dogs and cats to train the model on. The next function I won't need to explain in detail. Basically, it's just there to make things compatible with the Fast.ai library. Next, let's get our variables. Basically, just we're just preparing 1,000 images of cats to train on, and also the validation set, 1,000 images of dogs to train on, and the validation set, plus 1,000 images of dogs and not dogs, just images from the Flickr 8K set. Well, right now we're just going to get the entire set of images, but later on we're going to only select 1,000 from each set. Okay, now that that's loaded, let's get the preparation function, which then takes basically that set of images and generates our input variables for the Fast.ai library. The key outputs here are fn, or the list of file names, y, the numpy array which contains the target labels ordered by file names, classes, list of all labels or classifications, 0 or 1. Basically, 0 means it's either a cat or a dog. and one is not cat or dog. We're going to do cats separately and dogs separately. So our next order of business here is to create our data set, and we're just going to have either pictures of cats or pictures are not cats from the Flickr 8K data set. Now there may be a few stray images in there of cats, but let's just assume the vast majority of images in there are not cats, and we're going to create that data set here. And now let's put it all into the Fast.ai library. And if you've seen my previous video, which should be in the links below, you know that these lines of code will input these variables into Fast.ai. Okay, now we're done loading the data into Fast.ai. Let's train our model. We're going to use a learning rate of 0.01 and 5 epochs, just like in my previous video. And you can see here we have a 99.5% accuracy on the test set, which is basically 1,000 random images from the Flickr 8K dataset, which probably contains almost no cats. So this part, we're basically building the not cat classifier. So it looks at an image and tells either it's a cat or it's not. Now, here comes the big test. We're gonna test the same classifier that we trained on our validation set of dogs and see if our classifier thinks the dogs are cats. I mean, you can probably see this happening if we never taught it what a dog is. We just showed it pictures of cats, and dogs are four-legged animals of similar size as cats. So the classifier might think they're cats. So we're going to write a prediction function which we can take in the images of dogs, and then we're going to try to predict how many of these are dogs. So you see here, pred dogs basically runs our learn, takes in, this is a variable that's returned from the predict function, and that takes in learn, which is the classifier that we just trained here, and valid dogs, which is an array of images of dogs in the validation set. And then we're going to sum up this pred dogs variable. Keep in mind the maximum value we can get here is 1,000, and that's if we output 1,000 image, if it determines all of the 1,000 images are not pictures of dogs. So let's see. Okay, we're back, and you can see it determined 924 out of the 1,000 images in there are not cats, and of course not dogs. And we just fed it random pictures, and it just thinks that 92% of them, this is basically an accuracy of 92% if we actually feed it pictures of dogs. So this is lower than the accuracy that we get here, where we just fed it random pictures, and it thinks 92.4% of the dogs are not cats, which is, I guess, is pretty good. But let's see if we can replicate the same results by training it on pictures of dogs and then seeing if it'll mistaken cats for dogs. So let's prepare our data. Let's input this data into Fast.ai. And now let's train it with a learning rate of 0.01 on 5 epochs. Okay, the accuracy isn't as high as the previous one, but basically we're giving the classifier pictures of things are dogs, with 1,000 of those pictures, and 1,000 random pictures that are mostly not dogs, and then it's predicted with basically an accuracy of about 97%. Now let's feed it pictures of cats and see how many cats it thinks are dogs. Wow, unlike the not cat predictor that we did earlier, this one only thinks 128 of the pictures of cats. 128 pictures of the cats are not dogs. So unlike the not cat classifier we did earlier, which had about a 92% accuracy, here we only have about a 13% accuracy. That's not really good, but if you've ever gone through the Fast.ai lesson 1, you see that Jeremy also talked about how to improve your classifier by training the various layers. So let's try that. And before we do that, let's reload the data for our not dog classifier. Now that we've loaded our data, we also need to do something. Basically, we just need to look up and see what learning rate we should use. Now you probably saw that I used a learning rate of 0.01 before by default, but we're actually going to be more rigorous and find the actual learning rate we should be using here. You'll plot a learning rate schedule, see what the learning rate is over time versus iterations, and this one's more important. It actually shows the most optimal learning rate. And you see this function, we want to use as high of a learning rate as possible without this curving back up. But since this doesn't curve back up again, let's just use a learning rate of 0.1. And let's do the initial fitting again. Now I'm going to need to turn pre-compute equals false, and you can watch Jeremy's video in the links below if you want to know the details of why you do some of these things. And now let's fit to a cycle length of 1 with 3 epochs. This one will take a while, so let me pause the video. Okay, we're back to unfreeze the first layer. And now let's calculate let's run the learning rate finder again. Now let's plot the graphs. Okay, so here you see that it bottoms a little bit below 10 to the negative 3. So let's set our learning rates to 10 to the negative 5, 10 to the negative 4, and 10 to the negative 3. Use 3 different learning rates this time. Next fit will take a long time, so I'm going to pause the video again and come back. Alright, we're back, and we finished that round of training, and now let's see how well we can predict cats. And we actually don't want them to be predicted as cats. So let's see, out of the 1,000 pictures, how many of them do we predict are not cats? So you see, 349 out of the 1,000 images of cats are not dog. Classifier predicted as not being a dog. So there's about 651 images of cats that the classifier believes are dogs. It's not that great, but at least this is an improvement. And this goes to show that this classifier, although it may work if you train it on pictures of dogs and pictures that are not dogs, you train it on that, and then you give it a picture of a similar looking animal, a cat, it'll still have about a 1/3 chance of predicting that as not being a dog. I mean, it's not that great, but in practice, if I were building a classifier like this, I would probably use multi-class classification and make 3 classes. I'd make a cat class, a dog class, and a class for other miscellaneous things. And in a future video, I am going to show you how to do multi-class classification and do that on a set of fewer cats, dogs, and other objects than what Jeremy showed. And if you just heard, that was my cat in the background. But